Great. Great to have you all here. Session is serverless for frontends, I would say. Let's just get started right away. Let's not lose time. Before we get rolling, a few words about my person. My name is Florian Rappl. I'm a solution architect at a smaller company here in the Munich area called Smartpiot. We're doing mainly IoT and embedded computing, digital transformation projects, and distributed web applications. I'm also an open source enthusiast, work a lot with Microsoft technologies. I'm a Microsoft MVP for development tools, do a lot of projects, mostly scoped around either .NET or JavaScript, TypeScript, all the web stack. And I'm writing a lot of articles for various blogs and magazines. All right, I think that's me in a nutshell. So what are we talking about today in this session? The agenda I prepared, but please always feel free to ask questions if you feel that something is unclear. Is as follows. We start with a, quick run through what is serverless. I mean, what kind of advantages do we get by adopting a serverless model as compared to, for instance, a microservice architecture? Then we go over a bit to the front-end side. What are micro front-ends, and also what is this serverless front-ends, a pattern called Siteless UIs. So the similar journey that we took on the backend now on the front-end. And then, and that's where I want to spend the majority of the time today, let's get practical. Let's build something. Let's have a glimpse at what you've seen before, and theoretically, let's try to apply that in practice. Again, always feel free to ask questions, because it is meant to be an interactive session, and I think this way it's the best for both sides. I can see where you want to learn more about, and you, of course, get out with more knowledge, I guess, at the end of the day. Great. So from microservices to serverless, there is quite often a kind of what I would call a sales pitch, where we can see, let's call it a traditional model. You have, let's say, your backend, independent now if it's really microservices or, everything on a monolith. But the gist of the, let's say, diagram on top here is that you need to take care of pretty much everything, right? So independent if it's running on one box or several machines, you have the database, you have some logic, you need to handle security and all of that. And the practical sales pitch that you will hear quite often from, let's say, the serverless enthusiast is that instead of now having to take care of all of that and having maybe to orchestrate that and, of course, maintain it, what about if you could, let's say, leverage existing resources, let's say a database, a managed database, or already some authentication provider that gives you the security that you want to. And then the only thing you need to focus on is your backend logic, and maybe you place somewhere some front-end logic. And so instead of having, let's say, everything lying around and being maintained by you, you just focus on what's your real domain. Now, I mean, that sounds nice, but let's see, let's compare a bit microservices in particular with the serverless model, and where the serverless guys would say this is why you would choose serverless, right? So microservices, usually you, of course, ship that with the runtime of your choice. So you have the stack completely in your hands. You say, okay, I want to run it with .NET, for instance. So you need to embed that runtime yourself. You, of course, quite often choose an existing framework, let's say ASP.NET Core, but nevertheless, all the runtime completely in your hands. The next thing that you will need to do is you need to choose where you want to deploy that, right? And of course, if you want to deploy it, you also have, let's say, maintenance in your hands. Sure, that may be a virtual machine somewhere, but yeah, you are still in charge of giving it the right amount of resources, scaling it, etc., etc. And that, in the end of the day, requires some orchestration, especially when you have now multiple of these microservices. They want to communicate with each other. How are you doing that? How do you make sure that a new deployment, for instance, doesn't break that? Of course, these days, there are a lot of, let's say, helpful tools. for instance, let's say Kubernetes, where especially the orchestration part and the resource part are a little bit taken away from you, but still you need to make some decisions here, and you are of course in charge if something goes wrong. On the other hand, of course, if we look at the serverless side, there is no real runtime that you ship. The runtime is already provided to you. That of course has some pros and cons. The biggest benefit here is that you don't need to take care of, let's say, updating that or making it efficient. That thing should already be as good as possible. On the contrary side, of course, that gives you less freedom. So if there is something in the runtime that you would like to have that for some reason blocks you, there is no easy way to get around that. The publishing part is, however, where it gets really nice, because instead of now having to look, oh, where do we now publish this? Are there enough resources available, etc.? We're publishing to a provider. So that provider takes care of everything, that the right amount of instances is there, that, of course, if you want to, let's say, have the best performance worldwide, that it gets geo-distributed, etc., etc. So the provider is pretty much now your go-to part, and that is also the position that takes maintenance of them. And of course, together with the provider, you got some benefits regarding orchestration. So if you deploy multiple of these, let's say, serverless functions, as they are called, now the provider takes care that they can communicate with each other, provides already potential bridges, and that also, of course, new versions get in there quite, let's call it elegantly, that there are no conflicts and everything should just work. We know, of course, being in the industry for quite some time, just works is always a kind of marketing slogan. So there are always, of course, two sides of the coin, and there's no system that's perfect. But again, we gain something here. So in short, serverless, as the sales pitch beforehand told us, reduces the scope of the service to focus almost exclusively on the domain functionality, which means to us, of course, focus on the benefit to the end user that we really want to provide instead of focusing on technical aspects. Now, how can you, let's say, use serverless functions? Well, on Azure, there is a simple way called Azure Functions. It's not the only way, of course, but it's the, let's call it, out-of-the-box way. It gives you a serverless model. It's event-based. It provides you the automated scaling that you would expect. And we will see that now when we move on to the front-end space, it already gives you an end-to-end development experience. What does that mean? I mean, it starts already on your local machine that you can just develop there. You have an emulator. So even though the runtime is not in your hands, you still work against the system as if it would be in your hands, at least to some degree. And of course, there are other parts, let's say debugging, that you can do very nicely. And Azure Functions has a lot of things baked in. What we see, for instance, on the screenshot here on the slide is that even with an Azure function, you can code directly in the Azure portal. And that, of course, also may have, especially now for prototyping kind of work, some advantages. And finally, it supports different frameworks. Again, here there are two sides of the coin. On the one hand, of course, since the runtime is embedded, that means also the kind of different frameworks you can use are limited. But on the other hand, of course, there are some frameworks that you can use. Most popular choices, of course, are JavaScript and .NET, and everything that compiles, of course, to these two frameworks. So you can just use them out of the box, and they work very nicely, and everything is as you would expect. All right, that was our quick run through the serverless world. And now let's have a look on the front-end side. Let's maybe start with the pendant to the microservice, which is called micro frontends, a term that was, let's say, coined a couple of years ago. How did it come to that? Let's have a look at the web evolution for it. If you go back, now It's now almost 30 years, a long time, but for a long time, and I mean, even today, there was the monolith. And of course, there's nothing wrong with the monolith, so this will not be a monolith bashing session now, but it was, of course, a starting point in the beginning. You just had simple HTML websites, no logic. Then the first DGI scripts came out there, common gateway interfaces, most popular languages C and Perl, of course. And these were used then to let's say, receive then forms, and also, of course, provide a little bit of dynamic page generations. But still, it was always one system, right? So the backend was generating some HTML or directly having some HTML, and that worked really long, really well. But then in the beginnings of the 2000s, suddenly new, let's say, demands arised. And I think let's say, the first applications that really made sense that came a couple of years later, 2004, 2005-ish, there was Google Mail incoming, and that was a highly dynamic web experience for mail client. And the reason that, for instance, big scale web applications like Google Mail could achieve that was by doing a separation. So instead of having everything in one box and every action that you do going back to the backend and returning then with a new page, you suddenly could split up things. And you could suddenly have something that would later on be known as a single page application experience, where you say, okay, you got your page, and now the page is fully autonomous, and it will re-render parts of it by going to the backend, maybe getting some new data, or maybe getting a new, let's say, kind of sub-view, and then rendering it at the position where it should be displayed. And if you think about Google Mail, that makes a lot of sense, right? So you don't want to have this experience that your page always completely reloads. What you want is you click on a mail, and then only the part where the content of the mail is shown should re-render. And to achieve that, of course, there was a new kind of technique required, and that was called AJAX, asynchronous JavaScript with XML, later on more known as asynchronous JavaScript with JSON, or let's just call it fetch. And that, of course, was nice because there was another thing coming up, and that was the native apps, the mobile phone revolution. And what you wanted to have there is that also your backend becomes kind of reusable, right? So you have now a different client, not only a web, but now suddenly, let's say, a mobile app or maybe a native client somewhere. And you don't want to rewrite, of course, the backend. And of course, having that split made perfectly sense. But then, of course, something else happened, right? So you don't want or don't need the full, let's say, backend. You only need parts of it. And because you only need parts of it, parts of the backend will need to scale more than others. And as a result, you now started to split up your backend. That, of course, had other consequences too, since a lot more drive was into technology and providing these web applications. Teams grew, and with larger teams, it became clear that this model of everyone contributing to one larger code base is problematic. In the end, this is how the microservices emerged. So you say, you now divide your backend, you have now multiple parts, different teams can work on different parts of your backend. And at the end of the day, you may have something like a gateway or a backend for frontend that then is responsible either in general for outside requests, or let's say only for specific clients, like for your web application. So the microservices emerged, and now I think 3 or 4 years ago, we hit the same kind of problems with the front end. First of all, we wanted to reuse pieces there. Let's say you have your consent dialog that uses your company's domain designs, etc. But you have different web applications out there, and you want to reuse the same thing over and over again. If you deployed it now in form of, let's say, a library or something, then of course it gets into these different applications, but you need to rebuild those applications to make use of the latest consent dialog. If you want to keep it consistent, you would need to share it at runtime. So the, let's say, demand for reusable pieces at runtime became stronger and stronger. As well as the teams that actually were developing these web applications became larger and larger. And at the end of the day, the solution is very similar to the backend. So we now divide our frontend into different pieces where domain specialists will handle the different parts, and we aggregate them together in what I would call an app shell, which is, let's say, the empty application that just now knows, either on the server or the client side, how to aggregate these pieces so that, for instance, things that should go into the menu will end up in the menu and will end up at the right position. So that is a little bit where we came from. And let's now have a look in detail what that means for micro frontends. So first of all, the two aspects that I mentioned, on the one hand, teams and scaling of teams. And on the second hand, of course, composition of different parts in the actual, let's say, HTML. Now, on the left-hand side of this slide, we see, okay, what you can now do is you can actually vertically arrange your teams, which means instead of having groups of specialists and they all work in one large team, you now have cross-functional teams. And a cross-functional team that can actually take care of specific parts of your application. So in this example, you've got now, let's say, 3 teams, and each team contributes a part. So the first team, Team A, and the third team, Team C, they just contribute some fragments, whereas Team B takes care of, I would say, the application shell, and maybe even parts of the content there, right? And this Team B then uses the fragments coming from the other 2 teams. So that's nice, because at the end of the day, I mean, even though that's developed in a distributed manner with even, let's say, some shared principles, like, for instance, a design system that they all want to use, for the end user, that's just one consistent experience, one application that's out there, right? So all these pieces coming together and forming the application that you then see in your web browser. There are, of course, different, let's say, concerns that then arise there. And of course, one of the major parts is, how do you actually do the composition? There are, let's say, various ways to tackle that. The 2 major ways are either on the server side or on the client side. Of course, there are, let's say, hybrids, but in a nutshell, it boils down to these two, to this kind of decision making. And what you would choose, let's say either server side or client side, strongly depends on your kind of application. So if you care about first time user experience, or let's call it the real rendering time to see your application a lot, and that is, for instance, the case for e-commerce applications, then you would usually choose server-side composition, because there you can already pre-cache, can already have everything prepared. If you want to have a fully dynamic experience, think about things like the Azure portal, for instance, where everything is also very tailored to the end user, right? So you got your services, and depending on what kind of services you can use and you may have in your, let's say, portfolio, things should look different. Then you choose usually the client-side composition. There is, of course, as I mentioned, there is, let's say, a spectrum, but nevertheless, this is, let's say, the 2 major pillars that you should take into consideration. Talking about teams, again, let's have a look at how we now came to that, because at the end of the day, yes, microfrontend is a lot of things, and of course, there's a huge technical part behind it. But besides, of course, having maybe some technical framework or need to act here, it's quite often actually really inspired by rather the social aspects or how you structure teams. Because again, micro frontends just will give you another dimension of splitting your teams. Beforehand, you were rather constrained. Now, with micro frontends, you can do these cross-functional teams. So instead of grouping around a skill or technology in these kind of specialized teams, you are now capable of actually, well, forming cross-functional teams where there is really domain expertise in there and where every layer, so to speak, is really taken care of. And if you look at this picture in let's say, quite closely, you will see that the front-end specialist now, instead of having all the front-end knowledge and power combined in one team, it's now scattered. So people can then work independently on just one, let's say, fragment, and at the end of the day, they will also take care of the maintenance and ownership of that. One of the reasons to do that is the Amazon philosophy of the pizza teams. So that you have the following statement, especially, let's say, being applied to micro frontends, that 3 8-person teams are more efficient than one 24-person team. I mean, a 24-person team, I imagine to be rather large and ineffective by the definition. I wouldn't know how a stand-up with 24 people would look like. Everyone gets 30 seconds. Yeah. Can be good. So I think we are anyway always aiming for these let's say 5 to 10-person teams. But now with micro frontends, that also on the technical side makes sense, and there is no, let's say, alignment or not so much alignment needed between these teams, because that of course is one of the dangers. You just start, let's say, cutting teams, but suddenly you get all the overhead in, well, if you have a scrum of scrums, you know what I'm meaning, that suddenly you have really a lot of bureaucracy just to maintain the bureaucracy, and that shouldn't be the goal here, right? So it's only making sense if you can form teams that can work rather autonomous, independently from each other. All right. So as mentioned, just to emphasize that one point again, if you now have a structure of your application similar to the following sketch, where you say, okay, you now want to do micro frontends, you have your application shell, you have the different front-end modules or micro frontends, and then you have maybe different services. Maybe there's a one-to-one relationship between them. It doesn't really matter. Then you can also have the possibility of cutting your teams, for instance, in that mode, where you have a dedicated development team for the application shell. Usually it shouldn't be required to work that often. Once that thing is fully set up, it usually has barely any maintenance effort. But then what you form is full stack development teams, such that the ownership of a service and the, let's say, part in the front end is in the same team. It's of course not the only way to cut it. There are, as said, multiple ways, and it gives you a new dimension here. But the big advantage of these full stack development teams is that a change in the service can be immediately reflected in the front end. And I'm not necessarily talking about breaking changes. I'm also talking about maybe a new feature on the backend, right? So things really get then in the hands of the same people, meaning that it's just that the knowledge is concentrated there, no alignment needed. There is no, oh, give me your API specification, because these people, they made the specification, they made the API, and so of course they are the best developers to also implement it in the front end, at least as a team, not necessarily, of course, the specific developers, because they may still have dedicated knowledge about one thing or the other. All right, let's conclude the micro frontend section here to really focus then on the serverless part. Who uses micro frontends? I mean, the big question here is not, I guess, who uses it, because we could go over all these companies, larger and smaller companies, but the big deal is that who doesn't use micro frontends? Because even though you wouldn't, let's say, use micro frontends now knowingly, quite often micro frontends are actually used under the hood. Think about, for instance, things like a chatbot that you integrate or a third-party consent dialog service. These things bring a UI fragment to your page. And what you usually do there is you embed some script or an iframe, and then these things just work. And that's a little bit the idea behind micro frontends too. Of course, here just companies mentioned that really build micro frontend solutions, meaning all their websites are actually already composed of micro frontends. But again, using micro frontends, that may be already on your plate too. And then a little bit of advertisement. There are some books out there, and one book I also wrote out of micro frontends. So if you're interested in that topic, either buy that one. There are other great books. So for instance, Micro Frontends in Action by Michael Gers, I can, of course, also recommend highly. And then there is also a book out from O'Reilly, Building Micro Frontends. It hardly builds something. It's more theoretical too. But yeah, whenever you're interested in topic, just get one of these books, and I guess you will have something to read on and a reference. All right. So now that we got in depth in contact, at least theoretically, with what micro frontends are without having seen how to implement it, let's go one step further and then see already what Siteless UIs are doing and how we implement them, right? So we jump over that implementation of micro frontends. All right, so if you look at that slide, it looks very familiar, right? So we've seen that thing with the micro services and serverless, and actually the same concerns and let's say advantages that we've seen from going from microservices to serverless, we also see here. So with micro frontends, you usually get some kind of a runtime to do that composition that we talked about. So somewhere there needs to be something that says, okay, we now have this fragment, we should place it here, right? Also, we need to know where we deploy now our micro frontend. Let's say even if we want to do a client-side composition and therefore a static web app is enough, we still would need to allocate somebody, for instance, Azure Blob Storage to actually do that, or an Azure Static Web App to do that. And that, at the end of the day, requires, of course, orchestration. So let's say we now have some micro frontends in our application shell. We have our blob storage, so we can publish now the static web app. Still, when now some of the micro frontend changes, how does it get in there? How do we make sure that a new kind of fragment also ends up in the, let's say, in our application shell where it should be? So we require this kind of orchestration. We need to take care of that. We need to take care of the maintenance. Now, the promise of Siteless UIs is that you don't have a website somewhere, right? So there also you don't need to have a runtime. That is all taken care of for you. So no more decision making. Oh, how are these things then orchestrated? But similar to the microservices to serverless transition, we have now a provider. And of course, we now play by the rules of the provider. That means if there is something in the architecture there that's not possible, it will be very hard to get around it. And yeah, that's just something we need to know. So we trade convenience for, of course, constraints. Right. Now, knowing that, let's compare, therefore, what we now, we see the similarities between the Siteless UIs and serverless. As with serverless, we want to have development in a standard IDE, which means I can just open, for instance, VS Code and it would just work. There is no custom thing, or I need to have a custom IDE somewhere to make this work, or I don't know, it only works in let's say the website of the provider that I choose. That wouldn't be the model that we are after. We really want a model that's local first and that just works. If it's local first, we should still be able to debug this thing, right? So we need some kind of emulator. We know that from the serverless functions, from Azure Functions, for instance, we got this kind of emulator that we can start it locally, and the same applies here to Siteless UIs. But what we get for this reason is loose coupling. So there is no coupling now from the, let's say, provider to our application. So for instance, an app shell, when I do micro frontends, I mean, I can, of course, also do loose coupling, but most micro frontend implementations that you see, they already point to, oh, now I know the fragment is coming from here. That shouldn't be the case here because, again, the application shell is generic. It doesn't know our micro frontends here, our code. So in Siteless UIs, it's all loosely coupled. Still, to, let's say, couple that correctly, we need some kind of a self-definition. We know that kind of manifest already from serverless functions where you then define your endpoint specifically. You say, oh, I got a get endpoint, and this is, by the way, how it should look like. And you define all these things in a, let's say, declarative way. And as mentioned, we deploy without a runtime, so that is already given by the system. But as an advantage, we get instant availability. And just one picture I want to show you there before we now really do that hands-on and we experience that hands-on is that you can do then something really nice with it. You can stage these things. So let's take an Azure DevOps screenshot from a while ago. let's say you have different versions now of a specific module. Here it was some kind of an API management module. And what you can see is you can now have in different environments this module deployed in different versions. So in production, there's an older version than in most other environments here. And that's quite nice because suddenly your application really becomes like Lego. And you can say, oh, I got this one piece here, but it's not ready for production yet, but that doesn't impact all the other teams. They can still deploy and, let's say, ship newer versions. And that really makes the application quite powerful because suddenly you really are not bound in your release schedules to say, oh, okay, I want to release the latest version of my application, but I'm blocked by this one team who is not ready with their thing, right? Here not, because yeah, they are not ready. They are still on testing. They just don't deploy yet. Doesn't impact all the other teams. Right. So enough talk. Let's get our hands dirty. What we will do is we will use an existing framework for that. Call it Pyral. I will show it to you in a second. How that works is we get, let's say, one application for it called the Pyral CLI. That's similar to what you expect, of course, from Azure Functions. This thing will be our helper for starting debugging, for building, even for deploying. It's a little utility. Doesn't do much. Everything that it does, we could also replicate, but yeah, it's a good convenience factor. And then for the end users, they get everything now, the whole model shipped in kind of this front-end application, where they always get this kind of app shell, which is in this framework called the Pyral instance, and all the, let's call it Siteless UIs, the different parts, the different micro frontends, which are called here pilots. So together, they forming this front-end application that gives the consistent user experience. And everything is deployed to this provider, which here is just denoted by Py, and we just get that thing in here. Before we do it practically, show you a video what we could do with it. We will do a couple of other things, but I think the video is rather illustrative. We take as an example here Netflix. Let's say we know already Netflix did a lot of work in the microservice space. So let's just pretend Netflix also wants to do, let's say, serverless frontends. They want to scale their front-end development. Now, this is a kind of, let's say, it's not the real Netflix front end, it's just some mock application. But what you see is it's interactive, right? You can browse around. You have these favorites that you can go in there. And if you click there, now this is a selection of your favorites. Now, if a new team is, let's say, tasked to create something new, then they can just do it. They start a project in the command line. They then add the code. It's not so important what they code now. It's kind of a new functionality. Give me a random list of movies, which is nice. So they start coding it. All they do is here, in this case in React, that they write all the code, and at the end of the day, take care of the integration, the setup function. Now they can debug it to see if that works. So locally, you get this kind of emulator. We'll see that also in a second. So if they go there, well, they have an empty app shell. No other functionality is in there. Their thing is still empty because they're making use of components coming from other teams. So if they just, let's say, add the feed from the other team, so suddenly the functionality is there. Plus, of course, they now see the functionality of the other teams in the page. So they have the browse, the favorites, it's all there. The thing seems to be working. The team is happy. So at this point in time, they can say, well, good, let's ship it, because on the real website, it's not there, right? So only browse, favorites is there, nothing. So they want to ship this surprise me button with the random movie list that they just implemented. So what they need to do is they need to upload their functionality. So the first packet, they could directly also publish it, but here for illustration purposes, what is done is we upload it via the portal, right? So we choose here the graphical way, not the, let's say, DevOps way. They upload it, and now if they refresh the application, you see the new functionality is there. Just added it, and they of course could now disable it and do something with it. All right. So that's a little bit what you can do, just to give you a glimpse also what we will now look in there. And the whole Netflix application, I mean, this demo, I mean, was done by somebody who, well, didn't have any experience with the framework, also had no experience with React, but still could do it, I think, in 1.5 to 2 weeks. There's also an article about this one out there, many other examples, but I always like the Netflix one because, I mean, we can all attach to it very nicely and can also see the benefits. And what we can see in this kind of compositional screenshot here is that all the parts of the application, they're coming from different micro frontends, but they're always grouped. For instance, the favorites menu, well, that's of course grouped with the favorites page and with the favorites extension, so that heart that you can then see in all the watch tiles. And that's good. That's for a reason, because if that one micro frontend would be shut down, it should be consistently shut down, right? So if you don't have the page, you don't want to have the link. If you don't have the page and the link, I mean, it also doesn't make sense to toggle to have still on all the watch pilots the heart, right? So the functionality is turned off. So it should be turned off everywhere where fragments of it are. And this kind of consistency you achieve naturally in this platform. Right. If you have questions, again, just pull in. Otherwise, let's get our hands dirty. Before we now scaffold something, or let's do it while we scaffold something. So always switching windows here. So we do now two things. I scaffold something in the background, and in the meantime we look at something in the browser. So here I have an empty folder, but I will just now create let's call it a test pilot. And what we will do here is similar to the video that we've seen. We will just scaffold something. We just say npm init. So npm is the node package manager, and init just creates a new project, and we create a kind of a pilot project. So we say, give me a pilot. Now we need to give it a source. So that's our application shell, our application that we want to publish to. Let's call it sample pyral. That's just one thing that's out there. And then we can choose some options. Let's say, for instance, what kind of tooling we use, what application should bundle it. You can use whatever, like Webpack is a very popular choice, but something I always like to use is ESBuild, because it's very fast to install and just very fast to build things. And defaults just means let's skip a survey where I can select all the options. So while this thing is installing, which shouldn't take too long, but still, we can have a look at just a few sites. So first of all, I wanted to show you the site of the framework I'm using here is pyral.io. So it has a link to the GitHub repository and documentation if you want to have a look there. The second thing is the Pyral Cloud. So if you really want to publish somewhere, you can create your own feed service. This is what we call the thing that actually hosts all these Siteless UIs. Or you can use something out of the box, and we have it at Pyral Cloud. There's a free community version too. And you can host it in your own environment. In the Azure Marketplace, we got the feed service, also in a free edition. So if you want to, let's say, try that, you can do it here. And what I want to show you now is this kind of Netflix application in real life first. I forgot the URL. Netflix sample, I don't know. Let's see. So we got the code out there, and this is how the application looks like. It still has this surprise me button, right? And what I would now do is, with a different account, let me change that here. I will show you how this thing behaves when I turn something off, and how easy that is. So just bear with me, and alrighty. Great. So Here we see the currently deployed pilots. We could even, let's say, go to a different version, so that's always possible. But what we could do now, just to show that how, let's say, it behaves, I could now turn off a functionality like this random pilot, right? So I just turn it off, very simple switch. And if I now reload the application, let me do that. And you see, oh, the surprise me is now gone, right? And of course, this page and everything is also away. But it gets even better. Let's turn it on again. Let's say I disable the favorites. And again, the favorites are seen on some occasions. So we got to log in first. Let's do that. And if I now hover over something, you always see this heart, right? And you got the page, no favorites yet, but of course, if I heart something, let's do it here. Then now I got this Moonlight. A friend always tells me I should watch it. Maybe I should do it one of these days. So let's just disable now this micro frontend. Let's reload. And now you see the favorites is gone. Also, the heart here is gone, right? So if it's of course up to developer to model that right, but if you model that right in domains, then you get exactly this experience because you group things already and they very naturally just work together. And as a result, you can then just have this behavior. And you can do even more. You can have feature flags that things here are provisioned for the end user depending on whatever condition, a user account, a browser, whatever you'd like to, right? So you can have very dynamic compositions at the end of the day. Great. So that's about this Netflix demo. But now let's go one step further. I think it should have scaffolded successfully. Great. So what did we get? Let's have a look in VS Code. We have now this directory that I created. And it scaffolded this code. So I got a package JSON. I got already a source file in there. And of course, I can play around with it. Let's just start the application to see how it's going. Let's just npm start and see if everything works. So ready is good. So that is all that it took. And now I got an experience where I'm working against my emulator. So all I did was I came up with, I think, this tile here, and we saw a quick notification down there. Let me just refresh to have it. Hello from Pyril, right? And I also have something here in the menu, documentation. That's things I added here just to confirm. Here you see this documentation. So if I change the name to FUPA, I should immediately see that being reflected. So let's have a look. And now you see FUPA here, right? So I can now drive what this particular micro frontend brings to the table, but I'm doing it all in this emulator. So I didn't come up now with this kind of design. That's actually from this sample Pyril app shell, but that's all now delivered to me locally in form of an emulator. And this sample Pyril app shell, by the way, that's also available online. So I think the address is demo full Pyril.io. You see the same design here, but it has different micro frontends, of course. So here you could now play a game, for instance, say, oh, this is great. So this is now Super Mario. And but that thing now came in online, where the application shell is already bound to a specific feed delivering these micro frontends. I'm now working not online, but offline, so to speak, on my own machine. And so I got an empty app shell where I can only focus now on the functionality I want to develop. All right, so so much to that. I can do this. I can, of course, change things as I want to. I can create new pages if I want to. So I'm now doing that all in React, but I could also use other frameworks or plain HTML. Let me stay here in React. The React is just a small UI library that allows you at the end of the day to write your view in form of just functions that you then can use together with some special kind of enhancement for JavaScript called JSX. So that's an XML-like syntax here, and that allows me now to have something a little bit similar to HTML that I write here. So it looks very, very similar to HTML. And and I could easily bring that in. I can also lazy load stuff. So if I say, for instance, React lazy and then make a dynamic import, then this page will only load when it's there. So let's register the page. Let's call it foo. And then our page should be shown. And maybe here, instead of going out to the docs Pyro.io, to our documentation page, you can just maybe make a link using the React router, for instance. So always using the primitives of the respective UI library. So let's see. Foo, and now I'm on test page, and that all just works as it should, and which is great. And again, this page not part of the initial bundle, but lazy loaded, so on demand. Whenever you just want to access the page, the code for the page is loaded. Great. So that's how development of now new functionality goes. And what we could do now is with that, you can, as we already seen, you can also build it. So npm run build, for instance, does all that. Or you can pack it. So I can also use this pilot command here. That's part of the Pyro CLI. I can use it directly. But I could also publish it and make it a fresh flag that it just rebuilds. And then I would need an API key and a URL. So what I could do is I could create a new feed and publish it there. And if I use, let's say, existing feed, but with a wrong key, then this also will not work. But I can just now have maybe an example and go and maybe try to publish it to the sample feed. I'm not sure that should be the right address, but anyway, I will use a wrong key, AB, so it should be rejected. And we see invalid API keys applied. But if I supply the right one, then same thing would happen as with the Netflix demo beforehand, and I would just upload this just now in the command line. Okay, so that goes for development of new functionality. Rest here, of course, is just knowing the frameworks, knowing how to develop it, etc., etc. And then we can also have a look, of course, how development of some kind of an app shell looks like. So let's call this test app shell. And also here, we can make the npm init with Pyro instance in this case. So not pilot, but Pyro instance. I can also select here some options. So I can go, for instance, with Webpack 5 for the bundler, for the tooling. And I can also spare using the defaults, for instance, because then I would get this survey that I talked about. So let's maybe do this for now. Let's see. So it first gets the Pyro CLI. That may take a little bit. So now it says, do I want to have it in this directory? Sure. Yeah. Index HTML, of course. What kind of framework do you want to use? You can go even lower than Pyro itself, right? But Pyro gives you like everything out of the box. So do you want to perform the installation? Sure. The registry is the default one, which is great. Let's use the latest version. And TypeScript is always good. Some template if you have one. npm client. So a lot of questions, but at the end of the day, you can therefore tailor this to your development model. So let's say you already have some kind of a monorepo approach in your company. You can use it like that. Let's say you already have a custom registry where, for instance, your own packages, your own design system and other dependencies lie. You can use that. Let's say you don't want to use TypeScript for whatever reason, then you can also don't need to use it. Great. So I was started already. And in the meantime, we can see that it also scaffolded here something. So I got also similar structure, package JSON and all that. But in here, I also have now an index HTML. So I could now change, for instance, the title of my application shell. Great. So let's see. That all looks good. We emitted something. We're in development mode. And if I now go to localhost 1234, you now see this. This is, let's say, a standard template. Looks a bit like I think the ASP.NET Core standard template. You've got a few, let's say, tiles with a little bit of information, and yeah, that's it. Now you can say, okay, I want to tailor this. For instance, I want to already bring in some micro frontends. How do I do that? Well, model is simple. You call here the render instance function, but importantly, this one has an option called request pilots. This is where the pilots are actually, let's say, requested. And you can use, and we always, of course, recommend that, you can use a feed service. That's what is done here. It's going against our community edition of the Parallel Cloud feed service. But you don't need to, right? You can have maybe already some micro frontends determined, maybe embedded even in there. There's nothing against that model. You can do that too. You can have a JSON in there, and so you've just fetched this JSON. You can also do that. So you're quite free. So this thing doesn't care against what server you do. It just cares about that at the end of the day, you get back a so-called meta response. We'll have a look at that in a second. So that's actually describing what micro frontends are there. So I could now use a different feed. So this feed, let me just copy the URL. And I always like to use Firefox for this. Because if I get the JSON, then it, well, shows me a nice view of that, right? So items is an empty array and the feed is empty. Oh yeah, okay, so empty was the name of the feed, but items is an empty array. So let's have a look at the difference thing. I said before, and we have the sample feed. Let's look at that. And now you see items is not empty. Well, the feed is now sample, that matches the name. But now we get all these micro frontends, right? Like Mario or Space Shoot or Tower Def or whatever all these things are, but we get them, right? So we now got 6 micro frontends, which is great. And each is described like this. So you got a name, you get a version, you maybe got a description, then you have an optional author, and then you got some additional information that is important for, let's say, embedding that thing. Most important information is, I guess, the URL where the micro frontend now lies in form of a JavaScript. Okay, so that being said, let's change this here, not to go to empty, but to go to sample instead. Just do that. And suddenly you get all these things that you saw before and in our sample Parallel app shell, now in our own app shell, and they also just work. So I can also now just play Mario, and I think I never died here, but anyway, so let's just forget about this failure, but let's look at the achievement that we got here. So really, I was able to transport in things, and even with the right links in the menu, all right, from that were used in one application now in another. So this also, again, was one of the things why micro frontends were born in the first place. Now that all works, and I can, of course, graft my app shell as I want to, so change things, right? So all these texts that are here, they're, of course, all not cut in stone. I can just go ahead and say, I don't want to have this. And instead of hello world, I say hello Azure Global Virtual Summit or something like that. Also remove maybe the default tiles or change them, right? So I could just go ahead and say, oh, I don't like any of that, or I just want to keep one of these tiles that are given here as default, and I can do that. And suddenly this thing changes, right? I have a demo link for not found page I may not want to have in the menu, right? So I go ahead and I also remove this menu item here, and I'm happy. So at this point in time, I could now ship the code from my application shell. Let's have a look at that finally and be happy. So let's just run build. And that does 2 things by default. It, first of all, gives you a so-called emulator. And that's one crucial thing we talked about, the Siteless UIs. So you need to have this emulator to develop against it locally. So it just creates it for you. But second, it also generates now all the release artifacts. So looking at this folder here, Those things, they were just temporary use, so let's just remove them to get a little bit of a clean space. We got our release files, right? They are there. Our index HTML and our JS. Now that's of course minified, and some CSS minified again, all there. So they can be used in production. And then we got an emulator. That's a tarball, and then you can publish on an npm registry. So if you publish that thing, then other teams can use that to scaffold new pilots, develop against them, and ship code, right? Very, very conveniently. And as you've seen, I mean, a pilot may have been developed without one app shell in mind, but depending on that app shell, you can transport pilots very easily. So a pilot that was now used in the sample Parallel instance now was used in our own Parallel instance here, and it just works if, of course, the dependencies and let's say the API and all the underlying assumptions are met. So the less assumptions a pilot makes about its app shell, the more transportable it is. All right, I think a lot of information may have been too fast. I hope that with the recording, can either slow down or come up with one or the other question. If you have some questions now, of course, feel free to ask them. Otherwise, I say thank you for watching, and have a great one, have a great conference, and see you all around.
Okay, thank you, Florian. I see there are no questions, so I will stop the recording.